one. Hi everyone, welcome back to our channel Becoming a ROS Developer here at The Construct. My name is Rodrigo and we have a presentation for one of our students, Jiang, who completed his project, his real robot project for the course that we offer, ROS 2 Basics, in 5 days. So he's going to show us what a project he did on a real robot. So we're excited to see that today. Hi Lou, how are you?
Hi, good. How are you, Rodrigo?
I'm very well, thank you for asking. And yeah, whenever you want, you can start sharing your screen and
Okay,
showing us what you've done here.
sure. All right, let me share screen now. This one. Oh, hold on a second. Yeah, I think this is one I want to. Oh, yeah, let me share this one. Okay, I want to share the ROS object. Okay, I guess
I can see it.
now.
Great.
Okay, all right. I guess you can see now.
Yes.
Mhm. Yeah. So I guess By the way, hello everyone. Just the fact that this is kind of my third time doing this project because I have done Python C++ for ROS 1. So this is first time on ROS 2. Like I did before, I think the plan is I do this demo first. We run through the project, run through the experiment, and then uh, we look at the code and discuss.
Great.
Okay. So I have put in fact I have test run a few times already today. So I put the robot in the middle of the place, a random location, random orientation. So right now I'm just going to launch the launch file. So it will we expect kind of three sub project. One is find the wall at the surface. It will run towards the wall and turn towards the wall, run to it and turn around, and then going around on this playground, and also record the distance and the locations
Right.
from odometry. So let me start it now. And by the way, I hope, okay, okay, I can see my screen, just adjust this a little bit. Okay, yeah, let me start now. So first of all, you can see I'm showing the index, let's say index for the shortest. So it's turning toward the wall now, you can see it. So when the index changed to 360, which is the front of the now it's facing, now it's telling us a distance to the
Mm-hmm.
wall. Now it's turning around. So right now we wait for the index to be 180, which is on the right side of Robert. Now it's right there. Now I started the wall following process and the odometry recording.
Right.
So it's
Let
it's
me
a little
ask you
bit
though,
slow.
I
Go ahead.
saw it output a shortest ray index, what you talked about, but
Yeah.
it wasn't the shortest because you had
Oh,
an obstacle really close by.
oh
How?
yeah, okay. You mean the waterfall? Yeah. So that's I added some extra. We can talk about the coding later. So
Great.
I think the project didn't ask for it, but I kind of
You have a filter.
like to play a little bit. So I have part of software to identify object from the wall, so I
Oh, awesome.
can
Awesome. Yeah, we'll
rule
take a
out the
look at how
object
you
and
did
run
that.
to the floor. You can look into it. And also, by the way, again, this is not my first time, and Rodrigo gave me suggestion before. So actually, this time for the Python, I use more some of the libraries. Why reinvent the wheel when someone did it before? So
Oh, great,
we
great.
will see that. We'll see that.
Oh, I'm glad.
Also by the way, on the terminal, actually you can see two things. One is the distance to the wall, which is, for example, you can see like 0.2 something, and
Uh-huh.
also another is a feedback. So how far we have been running so far right now. For example, right now it's 4.5 meters. So that's kind of two things on the this screen right now. So that's
Mm-hmm.
we're looking at. So it will stop once we reach the start point, and I think that's the end of it. Yeah, here we go. Now it stopped,
Nice.
and just show you quickly. See, all those are the
All the
recorded.
result. Yeah.
Yeah, it's a little bit messy. You know, so X, Y for every locations, every second. So
Right.
that's
Nice.
the kind of the result of the
I know it's a
of,
strange direction to tell you to print that out in the terminal, but the idea is that you can use this then for a lot of things.
yeah, I know what I'm saying. Yeah, if we can, yeah,
You can plot it, for example, and then
yeah, we
you do
can
statistics on
we
that.
can do a lot of things.
Yeah.
Yeah, I agree. Yes. Yeah.
Awesome. Well, that was a perfect functioning of the project. So congratulations. Can we
Sure.
look at a little
Sure.
bit of
Thank you.
how you did it?
Okay. Yeah. Let's look at the code now. Let me just stop.
And you mentioned you had some questions and whatever. You can ask them whenever
Oh,
you want to, huh? Like so
yeah. So
when
actually,
we get
one,
up to it, whatever.
sure. Yeah. Actually, it's um, actually, it's once we look at the code, I think it should
Great,
be
great. We'll do it then.
that's I think that's where my question will start. So yeah. Okay. Let's see like this. Okay. Yeah. I guess you can see my screen with
Yep.
the code now, right? Okay. Yep. So just a brief explanation. Right now, I have two package under my ROS2 uh, workspace. One package is a customer interfaces. This is almost exactly same as the old practice during the course,
Yeah.
and all the other software I put under the package of a wall follower. So I don't know if we want to talk about anything about customer service because it's just super simple. It's just
No, I mean
the
it's on.
action
It's
surface and everything kind of just to like copy and exactly same as the
great,
class
great. No, and it's
course.
good that you put it separately because then another
Uh-huh.
package might use this custom
Yeah,
interface.
yeah,
So that's good.
yeah, yeah. Mm. Okay, now let's look at and I put all my software in this wall follower package.
Hmm.
And you can see I have like 5 Python files.
Yeah.
I have five actually because I have I make everything a class. So the action server, action client, surface server, surface client. So every modularize everything. So
Right.
the general is the wall following this one. By the way, we can also quickly look at the launch before we look at that one. So launch, I think that's also nothing fancy. It's just two server around the wall finder surface server, autumn record action server, and then wall following. So
Right.
this wall following. This one is a major. So we can look at this one first.
Mm-hmm. This guy will
Um,
have the client most likely. No.
Yeah, it will see it included kind of
Ah, nice.
yeah, include the action clients which is we look at for example the surface client. Surface client
Yeah, yeah. You added it as a class. Nice.
yeah have here see and action clients I imported both of them. So
Mm-hmm.
and by itself it has also it has its war following class. So we can look at the let me think. How about we look in the wall falling class first? And this
Yes.
is, I think, the simplest, easiest one. Um, to begin with, we initialize, the publisher to drive the robot, and also I create a kind of two kind of steps so we can, adjust this really, you know, um, for the linear step, angular step,
Mm.
and I use a mutually exclusive callback groups. So I have two callbacks. One is a timer and with a time period of half a second. And also I have a subscriber subscribe to the scan. And so I have two groups. And beside that, from the from scan message, I take out, I create 4 variables, we'll call it class, attribute, whatever call it. So one is a right, I call the right and front. Okay, the front is the the distance from the, in the front of the robot, how far the object from it, from the reading of the scan.
Right.
So the front, and also the right, which is on the right side of the robot. And the right front and right back is still on the right side, but like a 10 degree toward the front. That angle I read. And the right back is a 10 degree back from the right. So if you look at the callback routine, you can see scan callback routine. You can see, I, we can. I think we can't explain this every time. So I guess everybody kind of know it. So
You just
0,
extract the values there.
yeah, 0 degree is all the way back, and to the from to the and then go from right back and all the way to the front and to the left and all around 360 degree, and for the index go from 0 to 719.
Right.
So which means 360 is the front of robot, and the 180 is a straight right of robot, and then when I say front right, which is 10 degree forward, so I use index 200, and the front right back is 160. So that's I assume that's understandable now. So the timer callback is driving the robot around the wall. So you can see here. So I have a linear. We always have a fixed step. So I think I put it here 0.05, kind of slow. So the linear step always fixed. And for the angular step, so it depends. So if it's, for example, this is right is larger than 0.3, so which is too far from the wall, so we need to turn right. So the angular step add a negative to the angular, so which is turn right. And again, same, if it's too close to the wall, and we turn left. And also a little bit trick here is I compare, I'm right front minus right back, so which give us the information of the orientation of the robot relative to the wall. So so for example, if the right front is larger than right back, which means the robot is a little bit orient to the left side. It's running away from the wall, so we turn it back. Right. So similar here. So just a reminder, I can't do this. I like to, control the orientation a little bit to have a better driving result, and kind of using kind of a little bit different method I tried every time. So for example, I used before, I used, try to get the minimum distance and find the index. So from there to kind of to get angle. So it's kind of like this time I try use like just two angles. So this is kind of I think it's supposed to be faster, maybe not the best. So that's and again, the one facing the wall, it's in the wall is facing in front, it's quickly turn left. So that's what it's driving. That's it. And beside that, I have another method for stop. So when everything finished, I use it here. See, I just put it here. So when everything done, when the action client say, "Hey, I received," I action finished, it get out this while loop, and it will stop the robot there, and also, by the way, also kill the node, whatever that. So I have another stop here. Another small trick here is kind of trivial. Is I add another boolean as a stop command, which is when anybody asks for stop, beside it send out a stop command.
You have that
and
flag.
Also set this as a true. So when this is true, I will force here. I will force the to stop. So what
Oh, okay.
happens is because this uh I I worried if someone called the stop, well, I forced, wait 5 seconds, make sure, I'm sorry, 0.5 second to make sure this, the command send out enough time.
Right.
But during this time, the callback may, may,
May still go
maybe,
into effect because of the
yeah,
frequencies.
yeah, so it may come in, and although I send out stop here, but then this callback come in and send out
So it
another
does one more.
different,
Yeah, yeah.
and
I
keep
see what you're
moving.
saying.
So hey, you know what? Don't I tell
Extra
everybody to
protection.
stop? So this this guaranteed stops.
Hmm.
So that's yeah. So that's war following thing. So actually here I have a kind of question for Rodrigo.
Yes, absolutely.
Um, you can see for the this the
That
executor
multi-thread.
and the callback group is kind of new idea for the ROS
Yeah,
2,
I was gonna
and
mention that.
that's something I try to understand, but still I do admit there's still a lot more I need to understand.
No, but you
Uh
got the gist of it, I feel like. But
okay.
for right here,
Mhm.
I see that you have four threads. Does
Fourth
that mean
thread,
that you have
yeah.
four callbacks?
No,
Or
for actually, that's one of the question. For example, I have four because I like, so. For example, you have a like if I have two callback. I mean, two callbacks. Should I have only, is a two thread enough, or should I reserve another one for the, I don't know, for the main, for the spin, the
two is enough, and
main thread?
also you only need
Uh-huh.
one
Okay.
group. Because think about it, it's a mutually exclusive callback group. So you can put more
Yeah.
than one callback into one group. So if I see what you did there, that you wanted to do a group per callback, but you can put both
Yeah.
in one mutually exclusive callback group, and that way, since they're in a group of that are it's a callback group that's mutually exclusive, they'll be able to run parallel. Now I don't know how many you can shove in there. There must be a limit of how many callbacks you can put in a group, but
Oh.
yes, for the multi-threaded executor, you only need one per uh, callback, and then that's it. So, uh, of
Hmm.
course, this works because you're putting it like you're multiplying by two, but it you can do just one group.
I see. One group. You know what? Let's talk about a little bit more. By the way, another reason I added four because I have two nodes here. So the action client
Oh, oh,
will
oh, oh,
at
oh,
least, I
yes,
will at
yes.
least take one thread.
Right, right, right.
So
No, then
and
this is
then I
fine.
kind of, yeah, I kind of reserve three thread for this war following node. So you're saying maybe we don't need three, maybe two or even one will be
I'm talking about the
good.
callback
So
groups.
yeah.
So the
Mhm.
executor, I'm not absolutely certain, but that makes sense that you would have one more for each one.
One more for the action
But
client. Yeah. So. Mhm.
I don't know.
Yeah,
Did you
let's
try
go
putting
back
less
to the.
threads?
Yeah, actually, I think I should do more tests, to instead ask you questions.
You
But I
no, no,
kind
but
of lazy.
you might.
Uh-huh.
This might be an overkill, but it's works, right? Because you might have spend more resources that you need by having two callback groups and everything. But yeah,
Yeah.
I I think start with the one callback group, and that's it, and then
Wow.
just
You're saying I put both of them into the same callback group,
yes,
exclusive.
yes, and then
Oh,
in the subscriber, you can
yeah.
define
Okay.
the group. You just put the same group, and you'll see that
Okay.
one of they don't block each other if they're in the same group.
Oh, they don't.
No, they don't, because they're
Oh.
mutually exclusive callback groups, right? So uh, they're
Mhm.
exclusive of each other in that group.
Okay.
So that's why you can. And again, I don't know how many you can add there, but
But okay, but if they are in the same callback group, do I need to reserve two thread? For, like, in the executor I should reserve, for example, I should reserve three, which is one plus two thread for this two callback, or
I think
um
since you have the two callbacks and then two other nodes, that's fine with four. Yes, I'm not
mm,
100%, but I believe so.
Okay. Actually, that's come to my. I'm just going to my real question here. This will be a little. I think it's interesting. I just let me explain to you. So,
Yes. By the way, we
so
have
what?
5 more minutes,
Oh, okay,
but
okay.
don't worry.
5 more minutes for everything, or for my 5 more minutes for
For
this?
everything, yes.
Oh, oh, okay.
But I
Oh, I
mean,
didn't
I
know. I
I
didn't
know
know.
you haven't
Okay.
shown the odometry recorder, but
Okay.
don't worry about that. Just ask me your question, because I
Okay.
know it
Yeah.
worked because it was, and the whole
Yeah. Yeah.
every technique is covered sort of in
Yeah.
the
Okay. Yeah. And the
course too.
only thing you need for me, I think I will show you the the kind of objects future later. But let me ask this question. So this is I want you to see this is we have callbacks. So one is scan callback, one is timer callback.
Yes,
So they I guess they can interrupt each other. Is
right,
that
and
right?
that's why
So
you
I
do the callback group.
callback. So that means, if I have a call, during the timer callback. So so that's make me think maybe I shouldn't make them interrupt each other. For example, let's say I like at the beginning I got some, before I this timer callback, I get all this, my variable updated.
Mm-hmm.
And what if halfway here, for example, here, halfway into the timer callback, and it get interrupted by the scan
By the
callback,
scan.
and the scan value, all those value get updated halfway of the timer callback.
Well,
You know what I'm saying?
you could do
That may not
something
be
like
what we want. So I can I can create like a shadow, another group of shadow variables. At the beginning callback, I get everything updated. I don't, during this callback, I don't update it anymore. Use those kind of shadow variables. But this make me think during this timer callback, we may not want the scan callback to interrupt it, because sometimes we want, but sometimes we don't. So if we don't want it, maybe we don't. What I'm saying, maybe we don't want to use this, and I don't
mutually
know, whatever callback.
exclusive. I
Maybe we want
understand
it to
what you're
block.
saying. You could make
Yeah,
it work by the blocking of each other because
yeah.
you don't need them
We
available
want
all
it
the
to block
time,
each other.
right?
That's what I'm saying. Yeah.
So I understand what you're saying, but that's sort of like uh so that's sort of like saying, I can go around it, but if uh I would recommend this way because
I see.
you'll see. So if you increase the timer callback, the frequency of the timer callback to, let's say,
Mm,
instead of point 0.5, I don't know, 0.005, it goes super quick. Then that doesn't leave enough time for the scan callback to come in. So you'll see if you try and print a value in the scan callback, you'll see how the high frequency of the timer callback, which in this case is your controller sort of function, uh, is working over time, and it's taking the same value over and over again, and that can lead to a behavior you don't want, right? So because of the scan callback, you have, if you're blocking it with the timer, then you don't know what the new value is until it gets unblocked sort of, and it can enter and do that. But yes, you can do this like this, or you could do it by time. You don't have to,
mm,
for example, in the wall finder, sorry, you could
mm,
do something like, I'm not going to do mutually exclusive callback. Well, how am I going to do that if I don't have the values for the scan? Well, I can just block the uh, sort of the I'll do it by time, and I'll block the one of the callbacks by a certain amount of time with a certain rotation, so I know it'll rotate that much. So there's definitely ways that you can do it, but if you have these two, I don't. You'll see that at the beginning it might seem a little confusing, but once you get the hang of it, you'll have 2 or 3 callbacks per program. I've never really had many more than that, but you'll see how it's just really helpful. Um,
by the way, I'm sorry. I know it's late. Let me fire another quick question. So during the course, and also I have attended some the online course. So I see they use for example, they give example with a timer,
Yeah.
and inside the timer callback, they have like a sleep for like 1 second or 2 seconds.
Right. That's the
And but when they set up the timer, the
you
time
specify it.
they fire every half a second, which means it's for sure overloaded, you know, the whatever you call it, the 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 scheduler or the dispatcher of the operating system. You know what I'm saying? It's for sure overloaded.
If you add
But
a sleep, yeah, it
does it
makes not much sense, I feel like, because it's going to try to keep running
yes.
at that frequency and then you're adding
So,
sleeps on it.
yeah, so that's why I see in the
Might be a
example, for example,
mistake.
they put like a half a second in the timer, and then inside the timer they sleep 1 or 3 seconds. So what so made me wonder in the real application, in the real project, do we ever overload the operating system like this ever?
No, no,
Because
that might be a mistake from a transfer from, for example, a main loop that you had to specify a sleep so it runs on at a frequency you want before you put it into a timer callback. That's just up the top of my head. But no,
uh,
you don't need to like overload things like that.
I
You
guess
like
I guess you know most I can't say 100, but I guess most of the time we don't want to overload this. We want every
absolutely
task
yes.
to finish, and we have some extra time, so we don't want you use every single bit, I
Yeah,
guess.
yeah, and you'll see that a lot of the extra sleep things that's just like our human nature of trying to
Okay,
set like breakpoints in our logic, which
okay,
you'll find that sometimes you don't really need them. So it might be like an oversight that it's just you leave it there for yourself. For example, um, I saw that you have a sleep there. I don't know if it actually does anything. You know.
I do. I have a. Let me think. Yeah, here. But this is not real one. This is not a callback.
No,
So,
yeah, I know, I know.
I
It's not executing every time. So yeah, it's not a good idea to have a timer callback with a sleep, I would say.
okay. For
Because it's
example, I
gonna
think for
sleep and then
yeah, for
it's just
example,
gonna
this
interrupt the
callback.
whole point of the timer, which is you specify a frequency for it.
Yeah, I use sleep sometimes. For example, you know, why run the robot? I think it's here. I think I use why run the robot. Oh yeah, this timer do it by self. So I
Mm.
run the robot. It will yeah. I
What I
see.
recommend
We don't
now,
have to use sleep.
since we're here approaching the end of our presentation,
Oh,
first of all,
okay.
uh,
Uh-huh.
let me recommend to you're saying, you know, I've been improving a little bit, little by little. You have this
Mm-hmm.
timer callback, which is great with a bunch of if and else of what happens.
Mm-hmm.
And you even
Mm-hmm.
added extra steps, you know, like you have not only a right, but you have a front right. You have
Yeah.
a front left. You have things like that. Obviously, to increase the control you have of the robot while it's moving. So I recommend that you take a look at how you can do a PD controller. It's very simple. You just do another.
Oh, I see.
You can. There's
Yeah.
examples everywhere of a PD controller where you just import a class and then you have a set point. In this case, let's say the distance for the right side, and then you have a control variable, which is uh, how far it is from this set point, and that control variable then you send it, for example, to your angular velocity, and you keep
Yeah.
the constant x like you have. So then you'll see that, and then you set a controller frequency because otherwise it might run too quick for the scan callback to come in, you know, and it might get that you might see this blocking issue. But that's
Yeah.
just a way of improving the control, and then you can do PID. You can
Sure.
tune
Yeah.
the proportional integral derivative parameters that you know change the control, and this just the next step for implementing a simple controller like that. So that's what I
Sure.
recommend for you if you are interested in that. So take a look
Yeah.
at how you can do a
Okay.
PD controller, and
Mm.
you'll see how much smoother it runs than if and
I
else
see. I
statements.
see. I see.
And
Okay. Yeah.
yeah,
Yeah. Thank you. I'll
do
look
you
into.
mind stop sharing your screen so we can
Sure.
just
Yep.
say bye here? All right. Well, um, congratulations, Lou. Really, really
Huh,
impressive. And it looks
sure,
like every time you take one of these, there are new concepts. So at least you're taking something out of it, which is our whole objective here. So congratulations for your project. Very, very
sure.
clear.
Thank you.
And
Mhm.
I'm sorry to kind of uh, cut you off so suddenly,
It's
but we
okay.
have
I
another
understand.
presentation very, very
Sure,
soon.
I
So
understand. Okay. Yep,
don't.
sure.
But
Yeah.
again, congratulations,
Sure.
and
Thank you. Thank you. I'm
and
coming, by the way, I'm coming back. I think I'm coming back soon for the ROS 2 C++,
great, great.
by the way.
We'll expect you. We'll expect you
Sure.
here then. All right. Well, goodbye, Lou, and thank you
Sure.
very much.
Sure. Sure. Thank you, Rodrigo.
All right. Bye,
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 everyone.
guys. See you next time.